Welcome to Module 5, Lesson 3, Chance Experiments with Equally Likely Outcomes, which you will see is not necessarily the case with the experiment that we do that takes up the bulk of this lesson. Okay, well, and here is that experiment, okay? We have Jamal, a 7th grader, who wants to design a game that involves tossing paper cups. Okay, tossing paper cups. So Jamal tosses a paper cup 5 times and records the outcome of each toss. An outcome is the result of a single trial of an experiment. Okay, so outcome. So each one of these is considered an outcome. Okay, so there were five outcomes in Jamal's experiment here. Okay, and as you can see, if we looked, we could see that Jamal noted that paper cups could land in one of 3 ways. Okay, on its side, right side up, or upside down, and the collection of these 3 outcomes is called the sample space. So there are three outcomes in this sample space, and this is just a little bit of vocabulary for you to take in. So the sample space of an experiment is the set of all possible outcomes of that experiment, right? So for example, a very simple one that we all know about, when you're flipping a coin, your sample space is heads and tails. Okay, there are 2 outcomes that are possible. All right. So the sample space, again, another example of sample space when drawing a colored cube from a bag that has 3 red, 2 blue, 1 yellow, 4 green colors. Okay, all the the 3 and the 2 and the 1 and the 4s is irrelevant right now when we're deciding on a sample space, okay, because that sample space just includes the possible outcomes, not their probability. And for this example, that would be red, blue, yellow, green. Those are the possible outcomes of a pick from the bag in that case, okay? All right, so for each of the following chance experiments, list the sample space, i.e., all the possible outcomes. So go ahead and do that. What's that for numbers 1, 2, 3, 4, 5, 6. Yeah, 1 through 6. If you go ahead and do those and come on back and we'll check them. It's not a very difficult lesson, as you are coming to see. Okay, so let's go ahead and check those, and I'm sure you got all these right. If we're drawing a colored cube from a bag with 2 green, 1 red, 10 blue, and 3 black, our sample space, green, red, blue, black. Tossing an empty soup can to see how it lands. Yes, of course, right side up, upside down, or on its side. Very similar, of course, to Jamal's paper cup experiment. All right, next one here. We're shooting a free throw in a basketball game. Well, there's only 2 things that can happen. You can make the shot, or you can miss the shot. All right, and truth is, most of the times those shots are missed by most of us. Rolling a number cube with the numbers 1 through 6 on its faces. Okay, and that's your basic number cube that we're also familiar with. And it's all those numbers, 1, 2, 3, 4, 5, 6 is our sample space. Selecting a letter from the word probability. Okay, this might have been a little bit confusing maybe. I don't know, hopefully something's challenging in this lesson, but I doubt it. Those would be P-R-O-B-A-I-L-T-Y, which of course does not spell probability because you see we have two B's. Okay, so we're not going to list that second B in our sample space, and we have a second I Okay, we're not going to list that in our sample space either, because they go along with these outcomes right here. Okay, now the chance or the probability of selecting the B and the I are better than the rest of those letters, indeed, but that doesn't matter, okay? Because right now we're just talking sample space, and those are all the possible outcomes. Okay, all right. Next one, spinning the spinner. What might you get? Well, you could either get 1, 2, 3, 4, 5, 6, 7, 8, and that's it. Okay, those are your possibilities. Those are the possible outcomes. Therefore, those are your sample space. Okay. Now, this is where the lesson, if you're going to go ahead and do this, these flipping of the paper cups, okay, go ahead and find a paper cup. I'm going to tell you now, based on my paper cup flipping, and I'll show you in a minute the different types of cups I used. I actually used a plastic drinking cup that comes with our little water cooler here in the trailer. First go around, and then I went to a smaller paper cup with surprising results because I thought there would be a difference anyway. Whatever. But if you can find, I would just recommend finding the smallest little paper cup you can find, like maybe one of those Dixie cups, those little Dixie drinking cups that are about, I don't know, maybe 2 inches high, about. All right, if you could find those, that might make this whole experience that much more interesting. Otherwise, not so interesting. Anyway, go ahead and do that. Find a paper cup as small as you can and flip it 30, toss it 30 times and record your outcomes, and then we'll go ahead and answer some questions. Okay, so let's go ahead and take a look at what I came up with and see what you came up with. All right, so just to consider beforehand, do you think each of the outcomes has the same or equal chance of occurring? Again, this is something I should have asked beforehand, but I forgot I had written it down here. Well, I'm not sure what you might have said, but just looking and just based on Jamal's results, if you take a look at his results, remember right here, you can see he looks like on the side with his side landings right here, and here made up 3 out of 5, okay, and then his right side up and upside down were both 1 out of 5. So according to his very small sample, okay, small sample size, hardly big enough to base any kind of projections on, but he would have said, his would have said no. And if you had any experience at all, excuse me, with flipping or tossing paper cups beforehand, you might have also thought no. Excuse me. But anywho, that's a little bit too late to contemplate that. Okay, well then I wrote this too. If they do, we say they are equally likely. Okay, if these outcomes all have the same chance of occurring. Equally likely. Pretty simple stuff. All right. So I flipped, like I told you, I flipped 2 different cups. Now, I flipped that plastic Alhambra cup there, and here were my results. I had 28 on its side, 2 upside down. Like I said, not all that exciting. Okay, then I went and found a smaller cup, okay, which was paper, not quite a Dixie cup, a little bit bigger than the Dixie. And then I got 29 on its side, 1 right side up. Now, honestly, I thought the lower the profile, the smaller the cup, the more likely it would have been that it would not have had so many side landings, okay? Well, in my first 30 trials, as you can see, that was not the case whatsoever. It was actually even more lopsided towards the side, though how much more lopsided you can get, I don't know. But anyway, like I said, I recommend this little teeny tiny Dixie cup, and I could not find one here at school. But maybe you did, or maybe you could, or maybe I will later. I know I have some of these somewhere, and we can go ahead and run some more trials and see if that changes our outcomes at all. Okay, because again, a good experiment. Again, I was surprised. So my findings from here were so surprising that it makes me want to pursue this a little bit further, just to see if there is a difference. Because evidently you can, I mean, just by virtue of the shape of the cup, you can see that it's not an equally likely chance. I can't imagine any of you did not have similar results than I did, as I did with the more side landings. Anyway, yeah, just if anything, if something like this, doing a little experiment or a problem like this makes you want to go further and look further into a subject, that is the greatest thing in the world, because that's what we need. We need more inquiry. We need more thoughtful pursuance of math and science from you guys. Okay. Anywho, yeah, let's move on. Okay. Here we go. Now, exercises 7 to 12, using the results of your experiment. What is your estimate for the probability of a paper cup landing on its side? And again, this is using your results, okay? Using your results. Now, my results, okay, I didn't want to do all that at one time, but I did anyway, okay? Using my results here, I had 28 out of 30 landing on their sides. I'm using that first trial because the second one was not significantly different. And that was 14 out of 15, which is 93%. Quite the evidence that, as far as my experiment was concerned, there is not an equally likely chance of either of the three outcomes occurring. And you can see in terms of landing upside down, 7%, and then the next one, landing right side up. For me, it was 0%. Okay, and even though on my second round with the smaller cup, I did have one land right side up, it seems pretty obvious that would be the more difficult feat, as the base is smaller than the top opening. Okay, it just makes sense that these two would be different. That's for sure. Okay, but again, it's all chance, so who knows? You may have had quite a few more landing right side up than I did. Okay, so based on your results, do you think the three outcomes are equally likely to occur? And that is a big resounding no from me, according to my results. Your results, again, all of us, we probably have 14 of us in the class, probably 14 different outcomes. 14 different outcomes of this experiment. All right, number 11 just moves away from our experiment and into a different realm, the realm of the spinner down here. This might have tricked you a little bit. It tricked me at first, I have to tell you, because I read it incorrectly. But yes, it's using the spinner below. Answer the following questions. And A asks, are the events spinning and landing a 1 or 2 equally likely? And that would be actually yes. Okay, I originally said no because I thought they were saying of all three coming up equally, but no. But yes, 1 and 2 have an equal chance. And as you can see, we'll talk about this again later, we can actually split this a lot easier there to split it into 4 pieces. Okay, and we can see that 3 dominates 2 out of those 4, and 1 and 2 have 1 out of those 4. That'll help us answer some other questions. Okay, so are the events of the events spinning and landing on a 2 or 3 equally likely? And we saw what that looked like. Okay, here is our 3, here is our 2, and pretty obvious there. That is no. Okay, the area is not the same. So on a spinner, whichever number or section has that larger area, okay, it's going to have the greater chance or greater probability. Okay, so how many times do you predict the spinner will land on each section after 100 spins? Okay, so if we go ahead and we take a look at the spinner again, you can see it there, and I think I go over this again in the next page. But you can see the probability here because we've split it up into fourths, which makes it easier for us to do. Okay. All right, so we have 1 equals a 1 out of 4 chance, 2 has a 1 out of 4 chance, but 3 has a 2 out of 4 chance. Okay, just looking at our spinner again. All right, let's go ahead and oopsie daisy, and look. And I have to get up there. Okay, so our prediction, and again, 1 equals 1/4 or 25% chance, a 2 has a 25% chance, and a 3 has a 50% chance. If we go ahead and apply those percentages to the number of times, we'll find that we get 1. We can probably pretty safely predict out of 100 spins, 1 will come up 25 times, 2 will come up 25 times, and 3 will come up 50 times. All right? And the last task here asks you to draw a spinner that has 3 sections that are equally likely to occur when the spinner is spun. And then how many times do you think the spinner will land on each section after 100 spins? And this is how mine looks, like a peace sign kind of. A little messy, but thirds are quite hard to draw perfectly. Not impossible, but challenging. Okay, so so if yours looked anything like that, that's super. And each section has a 1/3 chance, or 1 out of 3 chance of being spun. So if I use that fraction, of course, I'm going to get this ridiculous decimal, 33.33333, right? Repeating 3's, which isn't helpful when I'm trying to come with a very static number. How many times do you think the spinner? This is not going to allow me to actually have one solid number. So when you get something like that, if you say about 33 and 1/3 times each, you don't want to have that sloppy, messy fraction in there. So use a range, okay? And from probably, 30 to 35 would be a safe approximation or safe prediction. Okay, so if you did anything that looked remotely like that, that is super. Okay, so here we go. We're at our lesson summary already. Yes, not even 20 minutes in. These are really flowing. I should probably consider doing a few more a day. Maybe you guys can zoom ahead if you'd like. Or maybe not. Because it is nice to be able to take it easy after you've been working so hard this year. Here we go, lesson summary. An outcome, again, this is a lot about the vocabulary, is the result of a single observation of an experiment. Okay, so thinking this in terms of outcomes. I want to use this language of math more regularly. The sample space of an experiment is the set of all possible outcomes. Okay, another piece of vocabulary, sample space. It's a set of all possible outcomes. And then we have the outcomes, of course, of an experiment are equally likely to occur when the probability of each outcome is equal. Okay, and we saw that only in that last spinner, really. Our cup experiment did not work. I don't know if it was supposed to be equally likely or not, and maybe it was for some of you, but I highly doubt it. Okay, unless suppose a bag of crayons contains 10 green, 10 red, I'm just doing this to have fun, 10 yellow, 10 orange, and 10 purple crayons. If one crayon is selected from the bag and the color is noted, the outcome is the color that is chosen. Okay? So the outcome is the color that is chosen. The sample space will be the colors: green, red, yellow, orange, and purple. Each color is equally likely to be selected because each color has the same chance of being chosen, simply because there are 10 of each color crayon. Okay, so that's it. I know, real simple. Good luck. Have fun on your problem sets. Any questions, which I doubt. But if you do, give me a call.